Okay, so for this one we have a parabola and then a linear equation. So parabolas, and this one has an equal, so I want to make sure I use the one that is a solid boundary. This is from transformations way back in chapter 5. This is stretched by a factor of 2, and then it's shifted down 2. So remember our regular parabola, just from the vertex goes over 1 and up 1. Because if you just think of x squared, when x is 0, 0 squared would be 0, and when x is 1, 1 squared would be 1. So that's there's no stretch on it. If it has a stretch, if it has that 2 out in front, that means instead of going over 1 up 2, 1, we go over 1 and up 2. If this was if this was a 4, we'd go over 1 and up 1, 2, 3, 4. So that's our stretch. And then the number on the outside, that's our up or down shift. So for here, we want to shift this down 2 units, and then over 1 and up 2 for the other stretch. If I plug 0, 0 into this equation, I have 0 is less than negative 2, and 0 that is not less than negative 2, so that means I don't shade 0, 0 because it came up false, so I want to shade the outside. For the second one, this is a line, and this is in slope-intercept form, so the easiest way to graph it is just using the slope and the intercept. This does not have an equal, so I want to make sure I use the dash one. My y-intercept in this case is 2 right there, so I'm going to start from 2. My slope is negative 1/2, so I'm going to run 1, 2, and drop 1. So remember, it goes rise over run, so our rise is negative 1, and our run is 2. And then if I plug 0, 0 in, 0 is less than 2. That is true, so I'd be shading below the line. And then that area out there is the solution set.